So good morning all. Continuing with the unit number 3, that is structured query language. In today's session, we are going to complete join expressions and views. At the end, we will have a question answer session. If you have any query, you can ask. So join relations. Join operations take two relations and return as a result another relation. Keep in mind, when you perform any join operation, there will be two relations. You are joining one relation with the another relation. So that is, it takes two relations, and as a result of the join operation, you will have another relation. A join operation is a Cartesian product which requires that tuples in the two relations match a particular condition. That is under some condition. That we have already seen what is the Cartesian product and how it will be performed based on a particular condition. It also specifies the attributes that are present in the result of the join. So the join operations are typically used as subquery expressions in the from clause. Normally, this join of the two relations are performed in the from clause. Now you are familiar with this from clause, select clause, and where clause. So normally, join operations are performed as a subquery in the from clause. So let's see the join operations with the help of example so that you can understand it in better way. For example, this is the relation course. I will take this example to understand various join operations. So remember this. First, we are taking a relation course. So this is our course relation. First column is course ID. Second column is title. Third column is department name. Fourth column is credits. And these are the respective tuples present in this relation. Next relation I am going to take is prerequisite. Relation prerequisite. So this is the relation course ID and prerequisite ID. What is this prerequisite means? This relation will consist to learn this course Bio 301, you need to complete Bio 101. To understand, to learn course CS 190, you need to complete CS 101. To understand, to learn course CS 347, you need to complete CS 101. So these are the two relations I am going to consider to perform various join operations. So take the note, prerequisite information is missing for CS 315. So this is the course CS 315. For this course, prerequisite information is not present in this prerequisite relation. For Bio 301, the prerequisite present Bio 301, Bio 101. For CS 190, prerequisite CS 101. And there is no prerequisite for CS 315. Another information, course information is missing for CS 347. Here it is in the prerequisite relation, CS 347 having the prerequisite CS 101, but this course is not present in the course relation. So these two information is missing in course and prerequisite relation. And try to keep in mind this relation because we are going to use this relation to join the different operations. So first is outer join. It is an extension of join operation that avoids loss of information. Keep in mind, this outer join will avoid loss of information. How it will avoid loss of information? It computes the join and then add tuples from one relation that does not match tuples in the other relation to the result of the join. Again, I am repeating, it computes the join and then add the tuples from one relation that does not match tuples in the other relation to the result of the join operation. So here it is, the tuples, those who have not matched, that tuples also is been added in the result of the join operation. So for this, they have mentioned it avoids loss of information. If suppose there are some tuples that they doesn't match any condition, then also the tuples will be added in the result of the join operation. We will see this with the help of example to understand in better way. So if suppose there is no matching relation, matching tuples, then it will make use of null values wherein that tuple doesn't have any values. So it uses null values to record or to add the non-matching values into the result of the join operation. So first is left outer join. This is the first operation, left outer join. So just see the query. The query is like this: course natural left outer join with prerequisite relation. Okay, so this course is having natural left outer join prerequisite with prerequisite relation. So this is our left relation and this is our right relation. So what this natural left outer join will do, it will join this whole course with the matching tuples in the prerequisite. And if in the course relation there is no matching values for prerequisite, then also that values has been added in the result, and for particular column the null value is assigned. So this is how the result is. The course ID, title, department name, credits, and prerequisite ID. So it will add all the relations, so all the tuples present in the course relation. That is, there are 3 tuples present in the course, that is bio 301, CS 109, and CS 315, and it will add the prerequisite values, prerequisite tuples in this result, and there is null value for this 315. As I already said, this CS 315 doesn't have any prerequisite. In that case, it will add null value into the result. So this is the result of left outer. This is the result of left outer join of course and prerequisite relation. Next is right outer join. So this is the way to do the right outer join. Course natural right outer join. Now you can understand course is a left relation, whereas prerequisite is right relation. So what it will do, this outer join, it will consider all the tuples present in the prerequisite, and if there is no matching for any tuple, it will add that also with the help of null values. So it will include all the tuples present in prerequisite, and here it is the result. So course ID, title, department name, credits, and prerequisite ID. So just see in the prerequisite, Bio 301, CS 13190, and CS 347. For this, there is no course information, so it will include null value for the title, department name, and credits. Because this is not recorded in the table course, so it will keep the null value for the respective attribute. And this is the result of this right outer join. Keep in mind, when you say right outer join, all the tuples from the right relation will be included. If there is no any matching value, it will be filled by null values. If you say left outer join, then all the tuples of the left relation will be included in the result, and if there is no matching value for the right relation, that value will be having the value null values. So this is the second type of right outer join. Next, again, join relations. These join operations take two relations and return as a result another relation. These additional operations are typically used as subquery expression in the from clause. So join condition. What is this join condition is? It defines which tuple in the two relations match. It defines which tuples in the two relations match and what attributes are present in the result of the join. What attributes are present in the result of the join. This is called as join condition. Now you are familiar with this condition. You can understand it in better way. What is join type? It defines how tuples in each relation that do not match any tuple in other relation based on the join condition relation are treated. So join type, it defines how tuples in each relation that do not match any tuple in the another relation are treated. That is it. With the we have seen different join types, that is right outer join, left outer join. These are the types of the join. So these are the join types: inner join, left outer join, right outer join, full outer join, and these are the join conditions. Natural, on, you can mention predicate, or you are using keyword and the attributes A1, A2, and A. So these are the join conditions. Natural, on, predicate, nothing but the condition, using these attributes. So these are the join conditions in the join operation, and these are the different join types. So now we are going to learn about the full outer join. Now you can understand what will be the result of full outer join. So this is the way to do the full outer join. Course natural full outer join prerequisite. Course natural full outer join prerequisite. What this full outer join will do? It will consider all the tuples from the left relation, all the tuples from the right relation. That's why it is called as full outer join operation. Now see the result of this full outer join. So this is the result of full outer join. We have seen in the left outer join, this tuple has been added with the null value, and in the right outer join, we have seen this tuple has been added with the null values. In the full outer join, both the tuples has been added along with the matching tuples. So it will not miss any unjoined condition. So that's why it is already said it avoids loss of information. You will get these values CS347, that is course ID is present and prerequisite present, but this information is not present. But this information is present. Course ID and prerequisite for course CS347. So it will avoid loss of information. Some information is present. Similarly, for this tuple CS315 robotics, computer science and credit 3 and prerequisite is not present. Still this information is present and this information is not present. Still this tuple is present in the result of the join operation. So this is how you will get the result for full outer join. Next is join relation examples. So inner join, course inner join prerequisite on this course.course ID is equal to prerequisite.course ID. So based on this matching course ID, that tuples will be a result of this inner join, and this is the condition. Inner join prerequisite on this condition. If this condition is satisfied, then that tuples will be added into the result. This is the query. Only two tuples are present because this course ID present in the course and prerequisite having this matching two tuples only. So next is left outer join on prerequisite condition. Course left outer join prerequisite on this course ID and prerequisite course ID. If you mention condition, this is the result. Bio 301, CS 190, CS 315. This tuple has been added into the result. The matching course ID between both the prerequisite and course relation will be considered in the result. So this is the left outer join based on condition. So next is natural right outer join prerequisite. So this is the same result as we get earlier, right outer join, and this is the full outer join using this course ID. We will get the same result, but we have used this course ID as a column for condition using the course ID. All the course ID between course and prerequisite will be added into the result. So diagrammatically, these are the way to understand the different joins. I have taken this image on the website, on the different websites on the internet, from the internet. So what is the result of inner join? The result of inner join is this. By looking at this diagram, you can understand what is the result of this inner join. Here it is the table 1 and here it is the table 2, and the intersection part will be result of inner join. Next, full join. Now you can understand by looking at this diagram, the full join will consist all the tuples from table 1 and all the tuples from table 2. Whereas left join will consider all the tuples from the left table, that is table 1, and it will exclude the tuples from the table 2. The right join will consider all the tuples from the right table, that's table 2, and it will exclude the tuples present in the table 1. So again, I will have another diagram to understand it in a better way. This is the inner join. In the inner join, you will get this is your left table, this is your right table. The intersection part will be the result of this inner join. In the full join, the left table plus right table, all the tuples will be included in full join. In the left join, all the tables from the left table will be included, and that are not matching with the left table will be excluded in the left join. Similarly, with reverse operation in the right join operation, all the tuples from the right table will be included and left table will be excluded. So these are the diagrammatic way of representation of different types of joins. I have taken these images from the internet. So again, if you want to understand with the help of queries, so this is your left outer join. How to perform this? Select star from table A, left join table B on that particular. So this is the result of this query. If you want to exclude this also, you can make the changes in the condition. Select star from table A, left join table B on that key where B dot key is null. If you mention this key is null, this part is excluded, and this is the result of this query. Similarly, for right join, you can mention select star from table A, right join table B on this key. So this part will be the result of this query. If you want to exclude this, just say where A dot key is null. This part will be excluded, and you will get this part as a result. So full outer join, select star from table A, full outer join table B on this key. So this is the result of this query. Full outer join. All the tuples from A as well as B table will be present in the result. If you want to exclude this part, just make the changes in the condition on key where A dot key is null and B dot key is null. So this part is excluded and this part is added into the result. And if you want to get this intersection result, just say select star from table A, inner join table B on that particular key. So this inner join will be the result of intersection of A and B. So these are the diagrammatic representation of the A square joins. Next part is views. So this is the simplest form. If suppose you have a big table and if you want a small part of that table for the view purpose or for the querying purpose, you can make use of this view of that table. We will see what is views. In some cases, it is not desirable for all users to see the entire logical model. That is, all the actual relations stored in the database. There is no requirement for some users to view some tables. In that case, you can make use of views. Only show the part of the relation that is needed for that particular database user. You can do this with the help of views. Consider a person who needs to know an instructor name and department, but not the salary. This person should see a relation described in SQL by select ID name department name from instructor. This user is not going to interest in the salary of the instructor. So this part will be important for that particular user. A view provides a mechanism to hide certain data from the view of certain users. So what this view does, it will provide a mechanism to hide certain data from the view of certain users. Any relation that is of the conceptual model but is made visible to a user as a virtual relation is called a view. Only small part of the relation is visible to the user, that's why it is called as virtual relation and it is called as view. So how to define the view? A view is defined using the create view statement, which has the following form. So this is the way to create the view. You have to say create view v as, and then you have to mention the query expression. Then you have to mention the query expression, where query expression is any legal SQL expression. Then the view name is represented by v. So you can give the name to the view after this create view, and then v is the name of the view. You can give any name to the view. Once a view is defined, the view name can be used to refer to the virtual relation that the view generates. View definition is not the same as creating a new relation by evaluating the query expression. Rather, a view definition causes the saving of an expression. The expression is substituted into queries using the view. So this is the example of view. So create view of instructor without their salary. So how to create the view of the instructor relation without the salary? This is the way to do this. You have to mention create view faculty ads. Create faculty ads. Select, and here is the query expression. Select ID, name, department name from instructor. Again, I am repeating how to create the view. Create view faculty ads. Select ID, name, department name from instructor. So view will be created with this name faculty. So if you want to find all the instructors in the biology department, you can make use of the view in the query. Select name from faculty where department name is equal to biology. So this view faculty, we can query over this view like this. Select name from faculty where department name is equal to biology. So create a view of department salary totals. You can create the view of this. Create view department total salary, department name total salary as. Select department name sum salary from instructor group by department name. So what this query will do? This query will do the department name along with the sum of the salary, and it will group by department name, and that will be stored as a view, one view as department's total salary, which will consider department name and respective departments total salary. You can define view by another views. It is also possible. So create the view physics fall 2009 as. Select course ID, section ID, building, room number from course section, where course ID is equal to section.course ID, and this is the conditions, and course.department is equal to physics, post or semester is equal to fall, and section dot year is equal to 2009. So this is the way to create the view. You can have n number of views based on the requirement. You can add n number of conditions. Now create view Physics Fall 2009 Watson as select course ID, room number from, and just see here Physics Fall 2009. From this view another view is created where building is equal to Watson. You can expand the use of view in the query or another view. So create the view Physics Fall 2009 Watson as select course ID, room number from this subquery where building is equal to Watson. So this is the expansion of the view. One view may be used in the expression defining another view. So already we have covered, but this is the database statements. A view relation v1 is said to be depend directly on view relation v2 if v2 is used in the expression defining v1. If directly v2 is used defining v1, then it is called as depend directly. Next is a view relation v1 is said to depend on view relation v2 if either v1 depends directly to v2 or there is path of dependencies from v1 to v2. So it is called as depends on. V1 depends directly to v2 or there is path of dependencies from v1 to v2. It is called as depends on. And next is a view relation V is said to be recursive if it depends on itself. So these are the different types of defining the view. First is define directly, depends on, and recursive. A way to define the meaning of the views defined in terms of other views. That is called as view expansion. Let view v1 be defined by an expression e1 that may itself contains use of view relations. View expansion of an expression repeats the following replacement steps. So repeat, find any relation v1 in e1, replace the view relation vi by expressing defining vi until no more view relations are present in e1. As long as the view definition are not recursive, this loop will terminate. We can perform update of the view new tuple to the faculty view which we defined earlier. We can do like this: insert into faculty values. These are the values you have inserted. This insertion must be represented by the insertion of the tuple into the relation, into the instructor relation.